Okay, very cool. So today I want to show you how we can improve security of our infrastructure. So we have an instance and the public AWS instance that has SSH exposed, even though we're limiting it using only our public IP, it's not very much secure. It's not a good idea to push even secure connections like SSH, even limited to IP address, outside the internet, because some bad guys can always exploit something. So what we can do? First of all, we don't have to use Bastion host. We don't have to use public IPs and public instances to connect to our private ones. This means we can completely remove this. We no longer need this. Very good. And let me apply this. I've already applied level 1. And perhaps you might have guessed from the branch name, we will use Amazon SSM, stands for Systems Manager. Let me readjust some outputs as well. We no longer have these. And there is actually one more thing. We will also, in our auto-scaling group, we no longer want to use this SSH key. Okay, like this. It is possible to launch an instance without a key. In this case, we'll simply not be able to SSH using our regular SSH, but it will remain usable. It will still run user data. It will still respond to our, for example, HTTP requests or any other way we use it to serve some traffic or connect to it. So let's wait until this finish creating, and we'll reapply once again. Sorry, I was trying to do it too fast. Okay, same way we did previously, I will comment it out just so it allows us to recreate the launch configuration without any issues, and then we'll enable it back. I think there is a question. Yes, Fadia.
Yes. So I had a question about like the load balancer that we set up earlier, and about the logic or the algorithm it's used to forward the request. I suppose it's round robin since we have used we changed the content of one of the index .html files in one of the instances, and one time it was that content, and the other time was our game. So I suppose it's round robin. Is there a way, or does AWS allow us to customize this politics or algorithm, or is it always round robin?
Mm-hmm. Okay. Yeah, good question. No, don't remember. Honestly, let me double check. If I get this document that I see currently on my page, let me show it to you as well. If I read it correctly, there is only round robin. Yes, it doesn't give you option to modify it, unfortunately. We're just sitting here and waiting until these two instances finish terminating and nothing else. Maybe if we deregister them from the target group, it could help, but I'm not sure. But yeah, that's pretty annoying. How much time it takes for autoscaling to destroy itself. It says no registered targets already. Okay, it should be it. Okay, very cool. Now we have removed our key. Let's return our autoscaling group, so it will recreate it from our new launch configuration. And let's also make it one instance. We don't need too many instances right now. Okay, very cool. So what I will do now is, let me explain this to you. Since we are using for instance type for AMI Amazon Linux, by default, it has so-called system manager agent. And one of the features of the system management agent is it allows us directly from the AWS console, directly from our browser, to create a virtual shell directly inside the instance, even without the bastion. What we just need to do, so we need to install an agent, but the agent is already there because of the instance AMI. If we have used Ubuntu, for example, or CentOS or any other, not managed by Amazon, not created by Amazon, we should have also installed the package for this agent and make sure it's started. But in our case, we are just adding additional permission to our IAM role. Like it will be like this. There is so-called managed policy that's already created for us. We don't even have to write a JSON. But let me show it to you how it looks like in AWS. It is Amazon EC2 role for SSM. And this yellow cube means it is managed by AWS. AWS created it for us, it maintains it for us. You see this huge list of permissions. We don't have to care about them. They already, if you open your AWS account, they will already be there for you, just so you can use it in your IAM roles or groups or users. So we attach our managed policy to here. And also, we don't need this policy attachment anymore. It was done just for the demo purposes. We don't need S3 permissions in our instances anymore. So we'll just have IAM role with directly attached this managed policy and the instance profile that remains untouched. And we run Terraform apply. And hit yes. Now, what has changed? If we go, for example, to our instances, check its IAM role, we will see that instead of S3, we have this AWS managed role for SSM with all these permissions. Next thing we need to do is go to Systems Manager, and Session Manager. Press Start a Session. Let's actually recreate our instance. Perhaps it didn't attach it properly or didn't start without proper permissions. Let's reboot. It shouldn't go away. Okay, looks like reboot didn't help either, so let's just scale our auto-scaling group and recreate an instance from scratch. That's some older sessions. Let me clean them up while we're waiting. Yeah, very cool. This new fresh instance were able to bootstrap properly. And so the reason for the error perhaps is because it did not connect initially because when we deployed it, it didn't have this required IAM role. But now new instance started from the very beginning with new role, and we're able to register. Now once it's there, we can choose it and press start session. And what you will see is a browser-based terminal. Response to what's within our instance. So we jumped through the encrypted secure connection through our AWS console directly inside our EC2 without even having to expose SSH, put secret key, which means we have increased our security significantly. And a couple more things that we need to do. We still have some legacy which in form of these security group rules for SSH. We no longer need them. We can remove them. Instance, and from this was private. Yeah, the only one that we have it is private. Yes. May you explain how to install SSM in Ubuntu, for example? Yeah, on Ubuntu. Oh, the question is how to install SSM on Ubuntu. And yeah, the answer is, let me find it, AWS SSM on Ubuntu. Exactly. There will be a package that you need to install and obviously commands to install this package. If you, for example, like Ubuntu server, let's say 20. It suggests using Snap. Never used Snap before. Very interesting. Looks like this new type of package manager. 1604 has vget and the package. So basically, I'd say kind of similar. So you downloading this binary and manually using the package, you installing these directly as a package to your node, and checking using status. Yeah, make sure it is enabled and started. Very similar to Apache. And in fact, yeah, if you want to use Ubuntu, you'll need to update your user data script so it installs not only HTTP and our game, but also this SSM agent as well. Yeah, that's how it works. Does it answer your question, Mohammed? Okay, very good. Cool. So then, yeah, we have completed our secure environment. What we can do now is add everything, commit, and create pull request. Okay, very cool. We no longer have to care about our public IPs and all this voodoo, and everything is running securely. Let's check out Trello. So today we did our first task even faster than yesterday, than last Tuesday. So this one already here on your board, and let's then move forward. Let's do something else today. The next part in our plan is Terraform modules. So for Terraform modules, I will need to destroy everything and start from complete zero. So in the meantime, let's have a short discussion. So most likely, majority of you guys, or at least someone, is familiar with like general concepts of programming. And in programming, there is a thing called function. Can anyone explain what is a function in programming? Fadi, Mohammed, whoever wants to go first.
If we're gonna define a function, for me, it's a code that we write when it like a dependent, if you can say, a part of code that can be like executed alone, has inputs like parameters and inputs, and like could give output, and can be reused and like in other, like in multiple parts of code.
Okay, very good. And also very important feature about function is that it hides complexity, right? For example, a developer, oh no, let's say that. For example, one really smart guy developed a function that calculates some mathematical equation, right? And share it with us. And we don't have to be an expert in math or expert in something that's hidden inside this function. It can be considered as a black box for us. We only provide parameters and expecting or receiving proper response, right?
Yes.
Yeah, and that's exactly what is really important in our case, especially when we further in this class continue to using not only modules and analogs of functions in Terraform, but open source modules that were written by somewhere else and published on the internet for everyone to use.
I have a question regarding like what you have mentioned in our previous session about like having alarms, or like about metrics and triggering the auto scaling automatically, for example, according to CPU usage and everything like that. We use CloudWatch to set up the alarm and everything, and it's set up and the action is auto scaling the like adding EC2 instances. Is there a way to test like this, like adding stress our
Yes.
currently running EC2?
Yes, totally.
Like,
and let me find the good comment for you. Stress CPU course. One-liner. How to stress test your CPU on Linux. There was a very cool comment that I always recommend. 1 second. Yeah, very, very good. This one, let me share it in our common chat. Yeah, it's 4i in 1, 2, 3, 4, do while and infinite do and done. But it works like a charm. It works without any issues, and you never have to install any additional tools.
Okay, thank you. Just one more question. Like in CloudWatch, we're given like after we choose the metric, which is like CPU utilization, we're given the option between it, like is it the CPU utilization of each instance or like the whole like simulated CPU utilization? And for me, I made the choice like the all of the running CPU EC2 instance CPU consumption. What do you think about this choice? Like, should I have done it by like we add a new EC2 instance, one like one only?
It's a balance always. So, for example, in case you choose if only a single instance has high CPU, this means, let's say, other are doing good and some bug on this, for example, on one of the instances, and it consumes all the CPU even though requests are low. Then it will scale the rest of them for no reason, right? So it kind of balance. It kind of, you always see how your exact application behaves in a given setup and make proper decision based on that. But on abstract level, when in a home lab that we're doing, it's very challenging to make certain decision without generalizing. So each option will be kind of good and at the same time not good compared to other one, but it's very difficult to for sure tell you use this option.
Okay, thank you.
Okay, very cool. So yeah, then let's move forward and create our modules. We'll create a separate folder, call it modules. And the first module, the first building block that we'll have is a module for our VPC. Very cool. So basically, entire level one solely dedicated to our VPC. So we copy and paste it to here. Basically everything except for Terraform TFRs. So outputs, variables. No, variables not yet. And yeah, and by the way, we don't need provider. Provider will be inherited. Let's for now go ahead with just main and outputs. In our main, we will do the following. We will say module VPC source and choose our local path to the module. Modules VPC. And basically pass all the parameters that's declared in our variables, like seeder, public, private, availability zones, and so on. It will be, let me move it to here like this. We copy it first. Public seeder, private seeder, availability zones, env code. Okay, very cool. And basically repeat all of these like here. So basically what we did is simplified our level 1 configuration from 100 or even several hundred lines only to this. Only this small building block for our VPC. Also, we can go even further and, for example, outsource the development of our VPC to, for example, some other team. Let's say we have a networking team who is responsible for networking and including cloud networking in our organization. And they might give you this module that you can just call and deploy a piece of your network. Block definition must be the yeah, I forgot the equal sign. But what exactly this VPC seeder equal var VPC seeder means? Do any one of you have any clues, any guesses? Yes, Mohammed.
So is it like the input variables to the module?
Yes, but why? Yes, but why we are passing this var into the input variable?
Because it may be different.
Yes.
Right.
So let me explain you this. So essentially, we can put anything we would like here. We can put it manually like this. 10.0.0.0/16, right? That's our actual VPC CIDR. And this will be accepted perfectly, right? But we already have these variables TF and Terraform TF vars where it is declared, right? So this means we just reading these. Let me move it back. We just reading our variables from our TF vars into main and passing it to the module, to inside our module, right? And it creates some kind of a tree, some kind of dependencies, right? But originally they are being read from Terraform.tf vars. But it doesn't mean it always should be var. It can be, for example, local if we declared some locals, or even hard-coded variables like we did like this. And it is very important to understand this. Okay, and let's try running this. Okay, some errors. Unsupported argument. Argument env code is not expected here. Do we have volunteers to help me decipher this error?
Is it because the module is not expecting an input, like we haven't defined some sort of parameters to our module?
Yes, exactly. I did this intentionally. Remember, I said, let's not yet put variables file to here, right? So in order to pass something inside a module, within this module, inside this module, a variable that named same way should be declared. And let me like first copy this Copy, paste. Now we have declared all the variables. They correspond to what we have in our module call. And let's run Terraform apply again, and it will work perfectly for this time. Not quite perfect. A subnet and declare manage resource used. Yeah, let's fix outputs a little bit later. First, let's sort out variables. Now everything works fine, right? But let me demonstrate it once again. Let's say I remove or comment out env code and availability zones. Let's actually run Terraform plan. What will happen? We were too slow to guess the answer. And here is our error. Exactly like I explained. Everything that we use in our function call, wherever we call our module, we should declare it in the variable. Okay. Now, regarding accessing properties of our resource, why we get previous error? Simply because we no longer have the resource called AWS VPC main or AWS subnet public or whatever. However, we still have them inside our modules, and this output, it is like almost identical, but it will actually be correct because within the scope of the module, these resources exist. They do not exist on a higher level over here. And what we can do is actually, instead of AWS VPC, we could have said module VPC ID. So basically, same way we are doing with our inputs into the module, we need to declare them as variables. We, vice versa, if we need to extract some property of a resource that lives inside our module, we are declaring it within this module in outputs, like this output, VPC ID. And on higher level, we can always reference to it using this syntax like module name, and the name of the output. So basically, same will be here like this. And not to confuse you, I will move this to the right pane and copy it from here. Public subnet IDs, private subnet IDs, and yeah, and like this. And let's run Terraform plan again. Very cool. And let me actually, just to make sure that we are on the same page, draw some diagrams that will explain what actually is happening. So first, we have our terraform.tf vars. actually like this, level1 / terraform.tf vars. So what happens with the values from terraform.tf vars? Where do they go first? Any ideas?
The variables?
No, they have been declared through variables, but where they are used?
As input for our module?
Yes, from within, and this input from our modules is declared in main TF, right? After that, we are passing it through module, and basically forwarding them into modules, let's say VPC variables.tf, right? And after that, they are used in different like resources as required, as needed, as we declare them in code. So processed, passed into resources. So basically in modules vpc/main.tf, right? The module itself creates the actual resources and extracts properties. And these properties are written and exposed using outputs. And these outputs in turn are being read by not by main TF, but actually they can, if we have some resource in the same file that's declared, that uses the result of the module, that can be even in the same file. But in our case, it's being read by our outputs.tf. And most interesting part happens next. Outputs.tf in level1 / outputs.tf, where it is consumed. How do we use it further?
Level 2 in data source?
Yes, exactly, that's right. Level 2, let's call it data.tf, our data source, and so on and so forth. And it is extremely useful exercise when, for example, you have a lot of resources and you're getting stuck and don't understand what goes where. Always try to find out what's our entry point and how you can visualize that. Always remember, you should always understand what variable goes where, how it is transformed, what happens with it, what output do you get, and so on. Okay? Does it all make sense? This and this thing.
Yes.
Yes.
Okay, very good. Let's then move forward and refactor the rest of our infrastructure. So we have a module for VPC. Let me check some notes from my side. 1 second. Okay, let's add a couple more modules, let's say for auto scaling and another one for load balancer. So we can move these to here. We can move our data source there as well. instance TF private security group hit there as well. And actually, let's do this. We can put it as part of our auto scaling since we no longer have any instances at all, and delete it completely. And IAM role as well. User data also. Provider outputs, load balancer, Terraform TF vars, variables TF, okie dokie. And here we'll create asg.tf, but instead of our original thing, we will have something like that. For now, let's do this. So this basically means that we need to declare these variables. It will be this is happening within our module. Basically, this variable means essentially what we pass into our auto-scaling module. And probably I should have started from the load balancer because we also need to pass things like load balancer RN and target load balancer security group and target group RN. So it will not work like immediately. Let's run Terraform plan and make sure that my guess was right. Yeah, exactly. It wants us not declared. Hold on a second. Yeah, we actually need to split our data source. Why? Because we have both AMI and also remote state data source in a single file. So remote state is not needed inside the module, but AMI can still live there. AWS security group load balancer. Why it's still telling me that it does not exist? I just created it. Okay, yeah, it's within it's within our module. So instead of querying it as a data source, we can connect to it as a variable that we pass. Let me find it. That we pass it over here. So in this case, it should be just var VPC ID. Let's try it again. Okay, very cool. And this one, let's replace it with var load balancer security group ID. Let me have it shorter. LB SG. And obviously declare it. And in our module caller, pass it. Cool. Today we have a lot of errors, but this is good. Let me explain this one, the next one. So basically, if we move our user data script back to the original location here, it will just work. It will work perfectly. But at least we will not get this exact error. That's for sure. See, a completely different one. But the question is, isn't user data supposed to be within this module? Isn't it a part of this building block of like instance? Isn't it integral part of this, I would say, reusable component? What is your opinion, guys?
No, I don't think like user data is like something should be inside the module. It's like depend on
But
the user. It's an
yeah,
input.
depend on the user. But this happens. This is okay when we're creating like universal module that can run any type of web server. But if we want to build a module that will exclusively run this web application, or in our case, this game, and should then we include user data inside? I think yes.
Maybe yes.
Yes. And anyways, there are multiple cases. Yeah, maybe you would like to, if you want to like have it completely reusable, and in fact, for example, in open source public modules, that's exactly the case. But that's because millions, not millions, but thousands of users are using this module for their own needs. But in our case, and maybe that will be a case in the future, the question is how we put this user data into here. And let me explain how this is happening. It should go via its full relative path. Where is our user data? Instead of just user data sh, it should go like that. No, not quite like that. Okay. Okay, never mind. I'll then give just an immediate solution. anyways, I was not planning to use this hard code. Here is how it's done. It then gives you the proper path to the user data script. Doesn't matter where it lives. So relative to this location. That's a special system variable in Terraform that gives you the path exactly as it's supposed to be for this particular file. And next, we just need to fix these couple of variables. So we need private subnet IDs and load balancer target group IRN. So let's fix private subnet IDs. So it should be just var private subnet ID. Oh, hold on a second. Just subnet ID. And var target group IRN. Let's copy this. We will need this later. Okay, very cool. Hopefully that's it. Hopefully we are done. Line 41. I forgot to save it. One more time. Variable target group IRN is not expected here. Can anyone point me where I made a mistake? Who is the most engaged student?
Have we declared the target IRN as a variable as an input like parameter?
In which file?
In
Can
the
you
module like
here?
the AS not in the VPC, in the ISG point, the variables TF, exactly, the TF.
Yeah, very good. Thank you very much, Fadia. So I forgot how I called it. 1 second. Yeah, it should be target group IRN. And let's run Terraform plan one more time. And yeah, another bunch of new errors. Yeah, let's fix them as well. It's becoming kind of boring. Unexpected. So, okay. It is private subnet IDs, not ID. this object with no attributes because after we did this refactoring, we forgot to apply our first level 1 state. And there is nothing yet in the remote state data source. Okay, very cool. Let's move forward and run our Terraform again. Very good. Now it's allowing us to plan this, but we are not there yet. We also need to create another module for our load balancer. So let's move it there as well. Let's try to do this quickly. We're already behind our schedule. I don't want to spend too much of your time, guys. Load balancer, let's declare its own variables. Let's do this initial setup and see which errors it will give us, and we just adjust our outputs and the variables properly, and this will mean we are finally succeeded. Okie dokie, very good. Let's fix these all things. Find in folder. If at any moment you have questions or something that I'm doing is not clear, please stop me and ask question. Okay? Okay, finally, let's revisit the rest of things. Load balancer, data source, auto scaling group, variables. Do we really need these? Perhaps no. In vcode availability zones, let me check that we're still using this variable. No, not really. We can get rid of it as well. Okay, very good. Let's run Terraform FMT. Let's add everything, commit, and create a pull request. And
But sorry.
oh, I think I did wrong thing. 1 second. I committed directly to main. That's not right. Luckily, we all know how to drop a commit using rebase. What we can do is like this and force push. This is what you wanted to say, Mohammed, or something else?
No, something else. Can you
Okay.
share the diagram on Slack?
Sure. I will do this after the call. Okay. One more thing before we merge pull request is that I will verify that everything still works, but I will do this offline, not because we already spent a lot of time today. So for now, that's all. I will share video and diagram as usual. And thank you for today. And I wish you good rest of your evening.
Thank you.
Goodbye.
Thank you. Bye.